Welcome to AI Frontiers, where we explore the latest research in computation and language. Today, we're diving into how machines understand, generate, and interact with human language. Imagine a world where computers can comprehend, persuade, reason, and understand the nuances of language. We'll be looking at 35 groundbreaking papers from August 7, 2025, spanning various topics in computation and language. These include tokenizer-free language modeling, persuasion dynamics, factuality and reasoning, and more. These advancements aim to make machines more human-like in their understanding and interaction. Join us as we explore the frontiers of language models and their impact on our world. Computation and language is the vibrant intersection of computer science and linguistics. It drives technologies like machine translation, sentiment analysis, chatbots, and advanced text generation systems. The field has seen tremendous growth with large language models and advanced machine learning techniques, enabling researchers to tackle challenges that were once thought to be insurmountable. Traditional tokenization methods struggle with languages that have complex morphological structures. Zakershahrak and colleagues introduce HNet++, a hierarchical dynamic chunking model for languages like Persian. HNet++ learns to segment text into meaningful chunks without explicit supervision. This model achieves state-of-the-art results on a 1.4 billion token Persian corpus, showing significant improvements in compression, robustness, and morphological boundary detection. Persuasion is a complex behavior involving understanding, strategy, and adaptation. Zakershahrak and colleagues use linear probes to study how language models persuade humans. Linear probes are lightweight tools that analyze model representations efficiently. These probes can capture various aspects of persuasion, such as the point of persuasion and the persuadee's personality. Linear probes can outperform more expensive prompting-based approaches. Language models often struggle with generating factual responses, leading to what's known as hallucinations. Chen and colleagues propose a novel reward function considering factual precision, response detail, and answer relevance. They use reinforcement learning to teach models to reason more factually. Their model achieves a 23.1 percentage point reduction in hallucination rate and a 23% increase in answer detail level, marking a significant step towards more reliable and useful language models. Let's highlight some critical insights across the papers. HNet++ by Zakershahrak and colleagues shows a 12% better compression rate and a 53% improvement in robustness. Linear probes by Zakershahrak and colleagues can identify persuasion points efficiently and effectively. Chen and colleagues' reward function reduces hallucination rates by 23.1 percentage points while increasing answer detail by 23%. These findings underscore significant advancements in language model capabilities and evaluations. Several common techniques and methods underpin these advancements. Linear probes are lightweight tools for analyzing model representations, computationally efficient but potentially limited in depth. Reinforcement learning is a powerful technique for teaching models to reason factually, though it can be computationally expensive. Dynamic chunking is effective for tokenizer-free language modeling but computationally challenging. Benchmarking and evaluation frameworks are crucial for assessing model capabilities, though they can be resource-intensive. In the paper, HNet++, Hierarchical Dynamic Chunking, by Zakershahrak and colleagues, the authors tackle the challenge of handling morphologically-rich languages. HNet++ is a hierarchical dynamic chunking model that segments text into meaningful chunks without explicit supervision. The model achieves state-of-the-art results on a 1.4 billion token Persian corpus, showing significant improvements in compression, robustness, and morphological boundary detection. This work advances tokenizer-free language modeling, particularly for complex morphological structures. The paper, How Do LLMs Persuade?, by Zakershahrak and colleagues explores the ability of language models to persuade humans. The authors use linear probes to study various aspects of persuasion in multi-turn conversations. Linear probes can identify the point of persuasion and the persuadee's personality efficiently. These probes can outperform more expensive prompting-based approaches. This work provides insights into how language models interact with humans in persuasive contexts. In the paper, Learning to Reason for Factuality, by Chen and colleagues, The authors address the challenge of improving factual reasoning in language models. They propose a novel reward function considering factual precision, response detail, and answer relevance. Using reinforcement learning, they teach models to reason more factually. Their model achieves a significant reduction in hallucination rates and an increase in answer detail level, enhancing the reliability and usefulness of language models in high-stakes applications. Looking ahead, future research could focus on several directions. First, there's a need for more efficient and scalable methods for handling morphologically-rich languages and complex conversational dynamics. Second, improving the factuality and reasoning capabilities of language models will continue to be crucial. Third, addressing bias and fairness in language models will require more culturally grounded and linguistically inclusive benchmarks. Finally, developing more robust and dynamic evaluation frameworks will be essential for assessing the true capabilities of language models. This synthesis was created using AI tools including GPT-Mistral using the model mistral-large-latest. Text-to-speech synthesis was done using Google's technology. Image generation was accomplished using stablediffusion. While the synthesized content underwent review by a human expert, some oversights may still exist. All references are provided for further exploration. Subscribe to our YouTube channel for more insights into the latest AI research. Stay updated with the cutting edge of artificial intelligence and its impact on our world. AI Frontiers explores the frontiers of AI to make our interactions with technology more meaningful and effective. Thank you for joining us on this journey through the latest research in computation and language. Stay tuned for more episodes of AI Frontiers. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This podcast uses archived preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by the archived preprint server.